This is the 2019 higher level question 2, rotation style of question. So this one is based on the logo for a coffee shop, and there's quite a bit of information that we're given. So it's important to read the question through carefully. So the sign includes a semi-octagon A, B, C, D, E, F. So it's half an octagon, that's important information. The line EG is a tangent from E, so that's a tangent from a point outside of the curve. The curve JKL is a circular arc. Now, if we look at that, we're not given the radius, so we're going to have to use some constructions to find that. The curve QRS is concentric with JKL. That means that it's going to have the same center. Concentric circles have the same center. So for this question, we're asked to draw the given elevation and end view. I've started that. I've drawn as much of the elevation as I can without needing to do any real constructions. So everything here is just information that's given in the question with no constructions. And again with the end view. Sign is rotated 45 through 45 degrees above point O. Point O is this one up here. As shown by the broken line, so that'll be coming down along here, and I'll draw in the rest of that later. So for part B, this question we're asked to project a plan to show the sign in the rotated position. What we're going to start with is drawing this logo here in the center, which is the bit that's based on half an octagon. And the information that we're given, so it's half an octagon, so the bottom half here matches the top half, and left matches right. So we've got 4 sections that are all the same. The distance from A to F across is 60 millimeters. That's given to us in the question, which means that this distance down here then is also 30, so half and half going this way. There's a couple of different ways that you can create an octagon. In this case, I'm going to take a line, 45-degree line through the center. And I'm basically going to use a square as one of the methods that we're going to do. So to find our points, we have B, C, D, and E. We're going to be using point of our compass on a corner of the square that we've just drawn. So I've taken a line from this corner here through the center up to the other side or down the other side. You could also just measure 30 above A. That'll do the same thing. Point of your compass onto point A. Pencil onto the center of this diagonal line, so halfway between A and F. Make sure it's in the center. Swing an arc from there. This point here is point B. Do the same thing from the opposite side. From that corner up there, swing this down. Gives us this point. This is E. And then we can do it from either side here as well. So that's this point. Again, all crossing through the center. And down here on our square. So this is C and D. So this looks like it's a complicated construction, but it's really one of the first things that you learn about how you're drawing an octagon. So that's the construction that we've used. So just having to apply it slightly differently. So that gives us the octagon and the base of the octagon down there. Next thing that we're going to do is look at the arc here on the side. So this is a tangent. So this height here is 40, so finding halfway, that's 20 here. Radius 20 arc. So from F also touches point up here up on top. Just drawing it lightly to start off with. That goes all the way up there to the top. What I'm going to do next is we need to draw a tangent, so we need to to this curve here. That's going to give us point point G. So we're going to bisect the distance, the line from E to the center. So point for compass on E, extend over halfway, swing an arc. Same thing from the center. That's just bisecting a line from the center to point E down here. Line through the middle. And again, now we're measuring the distance from there. from that bisector to center the circle and draw that out till it hits the side of the arc. That first arc that we drew, that's this one. That gives us point G. So now we can join point E to point G and giving us our curve there. You can then darken in that part of the curve there also. So that's our tangent, that's our point of contact. Final part that we need to set up in this question is finding the arc down here at the bottom, JKL. We're not given the radius, but we are given 3 points on the arc. So if we have 3 points on an arc, we can bisect 2 chords, and that will give us the center that we're looking for. So J to K is a chord, so joining J here to K, I'm going to bisect this line the same way that I bisected the line previously. And the center of an arc will be on this bisector. So J to K. So the center is somewhere along that bisector. We also have the line, we could have K to L, that's another one we can do. Or as we already have one, J to L is a chord, so it's a chord is any two, joining any 2 points on an arc. Bisecting this one, this is already bisected, so this point up here is the center that we're looking for. So point of our compass on the point that we just located up here. Pencil on J, check it against K and L, they should all be lining up correctly. And that gives us our arc here for this one. Doing the same thing now for our other points, so that's this arc. So again, just to recap, J to K is a chord, bisect the chord, the center is somewhere on that chord. J to L is another chord, we already had the middle of that one, we used it a while ago. So where those two chords cross, or those two bisectors of chords cross each other is this point up here, that's the center of that arc. Going to do the same thing now for the next arc. Again, we're told that these are concentric arcs, which mean that they have the same center. And we're given the point R. Point R is 10 millimeters above point K. So locating point R, point your compass on the center again, pencil onto point R, and we can draw this arc in here. And a line across the bottom. So that completes setting up the elevation. We've located all our points. I'm just going to label a few more of these, Q, R, and S, and we have all our remaining points. Next thing that we're going to do is we're going to find the end view off over here on the right hand side. So extend the compass out. So point O up here, this is the very bottom point K, so that's the first point I'm going to locate. Rotating and bringing this off out this way. This point here is point K, that's the end of our, that's the end of the new, or the end view in the new position. So that's represented here by that red line. So I'm just going to find that in the plan now. So whatever way you project stuff into your plan. My plan fits into this space here. So this here is the entire space of where that plan is going to go. So the basic principle for how this entire thing is going to work. So the remainder of this question now is just about finding a point in one view, projecting it into the original end view, rotating it into the new end view, and then projecting it into the new plan. Every single point is going to be done the same way, so I'm going to do a couple of them. Then I'll pause the video, work ahead, and I'll stop for any of the more difficult ones. So I'm going to start just by finding the basic outline of our object. So that's point J and L. I'll come back to doing the curve later. So project them onto the original end view. Rotate into the new end view. And then project from the end view into the plan. So this onto the ground, 45 degrees. So this is point J, and this point here is point L. And K, which we found earlier on. Same thing applies for, let's say, these points up here. So point is projected from the elevation into the original end view, rotated into the new end view, from the new end view into the plan. So every point must go from elevation to end view to new end view to plan. That's the process. So that's this point and this point here. So I'm just going to darken a small bit of the plan here so it becomes a little bit clearer what we have. The second line that I've just drawn in here is this one. First line that I drew was that top one up here. And then we got the two sides. So stuff is going to start to appear narrower this way, but left and right it's going to stay the same width. So this distance up here for those bars hanging down, they're going to stay the same, so they can be projected down one and two here. So that gives us the start of that there. Going to continue on doing the same thing, so I'm going to take the square next, then the semi-octagon. So again, point from the elevation into the original end view, into the new end view, into the plan, and so on. So same for the point at the bottom. So A and F from elevation to original end view to new end view to plan. And located in the plan. So each point is going to again continue on doing this the same way. B, C, D, E, they're all going to continue on. Now, C and D we kind of already have, or we have part of the information for it. They're on the same line as J, Q, S, and L. So we already have the line JL, so we can just project this straight down. This point down here is D, and this point here is C. So now we just need to locate point B. So again, B and E are in line, vertically in line with A and F. So we've got some of the information that we need for that already. So horizontal, projected into the end view, rotate from the end view, in the original end view, into the new end view. Into the plan. So this point here would be point B and point E here. Okay, curve would be done the same way. I'm going to do this curve up here first, and then we'll have a look at doing this larger curve down here then after that. So to do a curve you need points. which is the same as what we've done for everything else so far. You just need points. Now, we had obvious points here, corners. We don't have obvious points here now, so we're going to divide this up with our 60, 30 degree set square. The reason we're doing 60, 30 degrees is points will be above each other. As in this point and this point, they're directly above each other, so we're just going to project one down. It makes things slightly easier when it comes to drawing in the curves. So we've got that point up there, we already have that one. So 1, 2, 3, 4, and G. Each of those points, as every point previously, project from the elevation to the original end view. To the new end view. And into the plan. So that point was point 1, that's going to be directly below where it is up there. This is point 1. Doing the same thing now for point 2. So point 2 is projected from the elevation into the original end view, into the new end view, new end view, new plan. So point 2, again projected down this way. This is point 2 here. Point 3 will come down that way, same position. So original, new, so all of this is the same, it's just very repetitive. So like taking point 4 here, for example, there's nothing new. We're projected from the elevation into the original end view, into the new end view, and into the new plan. So if you can do one point, you can do every point. All points here are going to act the same way. Point G the same, original, new, and into the plan. So drawing in our curve. And then we've got our straight line joining E to G. So that's that curve. The remainder of this is done essentially the same way. So I'm just going to do half of it and then I'll show you the solution at the end. So this curve down here, again, divided up 60, 30 degrees. Let's find points. So we can take this point here through the center. And if I was to 30 degrees, is and it's not great. So we can take a couple of points. These might just need to be random points because the 60, 30 is 60 degrees is here, 45 is very close to S, so we'll take a point through S. That gives a point on the lower bit as well, on the other arc. And we probably don't need another one inside there, so that'll give us 1, 2 points on the outside. We probably need actually one inside here maybe. We'll start with just doing this side here, so this will be point 5 and 6 that we're looking for. So point 5, same as all previous points. So you can take random points on these curves if you want. Point 5 into the original end view, rotate into the new end view, from new end view to new plan, and then from the elevation down into the plan again. This here is point 5, point 6, so from the plan, from the elevation to the plan, from the elevation to the original end view, new end view, down to the new plan. So again, repetitive, doing the same thing over and over again to get our points. So that's 0.6. Can do maybe another point down here through this one, kind of halfway between the two. That'll give us 0.7. It's more for the point up there that we really need that. 0.7 down here somewhere. Elevation to original end view, new end view, new plan, and 0.7 there. So when you get all your points on one side, join up your points, you're finding the best curve that you can, joining them up there like that. The points on the opposite side are done the same way. What I'd suggest you do is you take this height here, mark that same height over here. So for 6 and for 5. What that means is this point and this point are at the same one. So when we go to find 0.5 down here, it's just a matter of extending the line across rather than having to redo the whole thing. So 0.5 can just be brought down here a little bit quicker, or the opposite side for 0.5. Same for the one the opposite to 0.6. As they're at the same height here, they'll be projected across up, but we already have that line. It's this one. That's 0.61 we'll say, and this is 5.1. Same thing for 7. 0.7 on this side. We already have 7 on the right hand side. That gives us 7 left there. Joining up our points again as best we can. Gives us the curve here on the left hand side. Gonna do the same thing now for our remaining points, points Q. Let's say for example this one here. That's on the line JL, we already have that. This here is Q. S is the same. And then we have just a couple of other points, like 2 more, and R should finish this out. So 7, this is 8 and 9, taking point 8 horizontal into the original end view, rotate it into the new end view, and then project it down from the elevation. Yep, this point here, that's 0.8. Same thing for 0.9. Original view. New view. It's 0.9. And then point R again. So points on the right hand side, that'll be done the same way. That's that side, same points on the other one. So again, taking the heights, 0.8 here, that's 8 right, this is 8 left. This point comes down on the same height as the 0.8 is over here. This one. And then again for 9, so 9 right here, 9 left here. project from elevation to plan on the same height as it is here, so that's that point. And that completes this question. That's the 2019 higher level question 2. So just the main thing to take from this is if you have any point in one of the views, like point D here for example, or point 2 or whatever, the process is the same. You take it from the first view that you have into the unmoved end view or elevation or plan, depending on where it's rotating. So from one view to the next, from here into the original view, rotate it into the new view, and then project it down into the third. So point 4 here for example, project it into the original end view, rotate it into the new end view, and then project it from the new end view into the new plan. Same with here, that's point 4 down here. So that's the same process for all of this question.